Hello, welcome to the course Introduction to Machine Learning, Linear and Logistic Regression, and Neural Networks using Python. In section 1.1, we're going to ask the question, what is machine learning? So we start off with some pictures of our furry friends here. And we ask the question, how do we as humans learn to identify cats and dogs? At an early age, parents, siblings, teachers point to the animals or to pictures and say that this is a cat or this is a dog. As this happens dozens of times during our early years, a model to identify cats and dogs is encoded in our brains. Using the model, children become able to classify whether an animal is a cat or a dog without help from others. This is referred to as concept learning in human psychology. Okay, how does this relate to machine learning? So let's start off with a definition. Machine learning is the scientific study of algorithms and statistical models that computer systems use to perform a specific task without using explicit instructions, relying on patterns and inference instead. Machine learning algorithms build a mathematical model based on sample data, known as training data, in order to make predictions or decisions without being explicitly programmed to perform the task. The source for these definitions is Wikipedia, so you can go to this Wikipedia page to get more information. How does this relate to identifying cats and dogs? The examples we are shown in our early childhood constitute the training data. The information encoded in our brains is the model based on this data, and in later years we are able to perform the identification using the model without using any further explicit instructions. Okay. So in machine learning, there are three broad areas of application: classification, clustering, and game playing. Let's first talk about classification. And we come back to our pictures of cats and dogs. For classification using machine learning, the training data consists of thousands of images, each labeled as cat or dog. Based on the training data, the machine learning system learns a model to perform the classification. And when a new image without the label is shown, the system uses the model to make a prediction of cat or dog. So the key point here is that the training data consists of the images as well as the labels for classification. Okay, so let's move on to clustering. And here we have pictures of bicycles and cars. So for clustering, using machine learning, input consists of images, cars and bicycles without the labels. The machine learning system is used to find patterns or clusters in the data. In this case, we would expect two broad clusters, cars and bicycles, and if there's sufficient data, the system may also find subclusters, convertibles, two-door cars, four-door cars, road bikes, mountain bikes, blue objects, and so on. So for clustering, the key point here is that the input consists of the images themselves without any labels. And the idea is to find patterns within the images. Okay, so let's move on to game playing. Here is a Go board, and for game playing, such as Go Above, the machine learning system is encoded with the rules of the game, how to move the pieces. And through self-play or provided with a database of games, the machine learning system learns what moves to make at each turn to ultimately win the game. AlphaZero program that plays Go, chess, and shogi was trained solely using self-play in a short period of time and was able to beat other systems convincingly. So you can go to the AlphaZero website at Wikipedia for more details. Okay. So the three examples we just saw highlight the three broad areas of machine learning: supervised learning, unsupervised learning, and reinforcement learning. So in supervised learning, it's the process of learning a function that maps input information to labeled output information. The input-output information is called the training data, and the learned function is then used to predict output labels when new input information is provided. Applications include regression, image classification, language translation, spam classification, and auto-completion, and so on. For unsupervised learning, it's the process of learning previously undetected patterns in a dataset with no pre-existing labels and with a minimum of human supervision. So applications include clustering, data mining, and so on. And then for reinforcement learning, it's the process of learning what actions to take given the situation so as to maximize a reward. So the situation would be the configuration of pieces on a board, and the actions are the moves to make, and the reward is winning the game. So applications include game playing, Atari, Chinese checkers, chess, Go, and other games, and industrial control and other applications. The focus of this course is going to be on supervised learning, and we're going to talk about linear and logistic regression and neural network approaches for supervised learning. So we will talk more about those in the next section. So thanks, and see you at the next lecture.